Okay, one is 8 neighborhood pixels are there. Okay, and 4 neighborhood pixels are there. You can see that adjacency, pixel adjacency may be asked one question. You can see I discussed this yesterday. Yeah, this is the example of second diagram is an example of 8 neighborhood. First diagram is an example of 4 neighborhood. Okay, and so I discussed about sampling and quantization also yesterday. What is sampling? Explain about image sampling. I discussed very briefly, not too much detail. What is sampling means you should be able to write basic idea. So if I could share any other PPT about sampling, I will share. Sampling is simply like a digitization. Just one second. I'll share another PPT. Sampling is as I discussed yesterday, is simply like a digitization of coordinate values. You can see here sampler and quantizer will be there while you are converting analog image to digital image. Who can see the transcript? Participants enabled. Okay. So quantization is digitizing the amplitude values, as you can see on the screen. This is very important. And second is sampling is digitization of coordinate values. And next, I added one slide that differentiate between the sampling and quantization. One slide I've added in this. Digitization of coordinates, digitization of coordinate values, digitization of amplitude values. So here also you are drawing the like a time and amplitude you are taking here in case of sampling, discretized, continuous. X-axis you are taking time, that is discretized. Y-axis you are taking amplitude, that is continuous. And here your y-axis you are taking time, that is continuous, and y-axis, x-axis you are taking time, that is taking continuous values. Y-axis you are taking amplitude, that is taking discretized values. And the simple observation is like the sampling is always comes before the quantization. Whenever you want to convert or transform, just one second, I will post a message in that. If somebody is not joined, I'll ask them to join one screen. Okay, so there are different like you know, like sampling determines the spatial resolution of the digitized images, whereas quantization determines the number of gray levels in the digitized images. So each and every process has its own a specific significance. Like when it comes to sampling, sampling is bothering about resolution, spatial resolution, and whereas quantization is actually having more focus on the, focus on the gray levels in the digitized images. And here you can see that other difference are there. A single aptitude value selected from like that, you can read these 2 points. So this is a basic idea. as you see, sampling and quantization, basic idea. And next important topic is, maybe already I covered 3 to 4 questions which you can see, you can prepare for the exam, like applications of image processing, one question, and other question is different metrics. Different metrics or different distance metrics or distance measure. That is one second question. And third question is, what topic I've explained? Histograms. Histograms also I've explained idea. And next is, because this time I have given two sets paper. I also don't know which set will come. I have given two sets. Maybe some of questions are a little common. So here one more important question. So you can prepare the histogram. This is also very important. Simply you can write it on your own, like histogram diagram, like a gray image, how the histogram, x-axis what coordinates you are taking, y-axis what your x-axis what you are taking, pixel intensity level, y-axis number of pixels, if it is 0 black, if it is white 255, and if it is completely having black pixels, more number of black pixels, how histogram looks like, completely having white pixel, how histogram looks like. So like that you can take many number of example and you can draw. And histogram equalization, this also you can write. So histogram, you are basically converting an image into basically you are converting an image into a representation, a graphical representation, and this is very important. You can write, and there are some mathematical representation is there, that also you can add if you want to. If you have more knowledge on the subject, you can add the mathematical representation as well. That is there in the other PPTs. So here, one of the important points is noise. Now, what is a noise and what is noise based modeling, and what is a noise in the images? Generally, when you take an image, it will be getting some errors or some random errors may occur. So the real image may be degraded. Random errors may occur, so real image will be degraded, and this is referred to as noise. This noise may occur at any stage. When you are capturing the picture, the noise may occur, or when you are transmitting the picture, the noise may occur, or when you are processing. So at any stage of the processing of the picture, you can have some noise in the images. Are you getting what I'm saying? Hello? Somebody respond.
Yes, sir.
Yeah, I'm just talking about noise in the images, where when you capture an image, it is going to add some noise or error may occur, random error. The image can be degraded because of the noise. So this is independent of this may be dependent or independent of the image content. The image may be different or noise may be different. And so this noise is added to the images. So the image may not be as clear as you think or I think. So so noise, how do we describe the noise is by using the probabilistic characteristics. You might have studied probability and statistics in intermediate. You know already what is a probability, how when you toss a coin, what is the probability of getting a head, or what is the probability of getting a tail. Like that, probability is a fundamental idea. So when you are trying to explain this topic, we are relating it to the probability theory. And by using this probability theory, we are going to explain the noise in the images. And there is some noise which we refer to as idealized noise, which is also called white noise. which is also called white noise. So we also refer, there is a special case of this white noise, we refer to it as Gaussian noise. A special case of white noise, we refer to as Gaussian noise. And we write the probability distributed function and density function, PDF. In simple, we call it as PDF. Probability density function for the Gaussian curve. So you can see here image, one image is there, and this image, when we are processing that image and somewhere the noise is added, and you can see that how the noisy image is there, how original image is there. The left side you can see this is the, what is the bird name? Guys? So there is a bird in the picture. This is not necessary for us. There is a bird in the picture, and when you process this image, somewhere the noise is added, and this particular noise you can observe in the image. So this we refer to as additive noise. Additive noise. There is a two types of noise, either multiplicative noise or additive noise. So when the image is transmitted through some channel, noise which is usually independent of the image signal occur, and this will cause the degradation. And this is referred to as additive noise. For example, so here you can see that f of x comma y. The image, image is a image can be represented using the function of x comma y, and where noise and input image g are independent variables. If you want to understand very clearly, like here you can see, just one second. Only Shivakirti is responding. Okay, so here you can see that a of x comma y is equal to h of x comma y plus b of x comma y. You can see this. If you want to represent it mathematically, about how noise can be occurred in the images. So here a of x comma y is a noisy image. It is a function of noisy image. The final image you get after noise is added. And here you can see that h of x comma y is of the image noise. We are considering that h of x comma y is the image noise, and b of x comma y is the function of original image. You got the idea? Anyone can tell what I am trying to say in this topic in simple words? Type in the chat box. If you are not able to say, type in the chat box. So what is the basic concept of noise in the image? Guys, are you following? Do raise your hand. Signal dependent degradation, Amog. Signal dependent degradation, okay. Anyone? Error that usually occur, Manogna, Sai Manogna. Sai Manogna, you belong to this class only. Yeah? Error that usually occur when image is transmitted or processed. Error usually occur when correct only. Right. Error may occur during the process of the image while you are transferring. Noise can occur during image capture transmission. Very good, very good. So you got the fundamental idea. Even I also don't want to explain too much. I'm just giving you a brief about basic idea. And they are transmitting the image when you are, there can be some noise that can be added that will degrade the image, that may be dependent or independent of the image. So here a of x comma y is a function of noise image. As you can see, h of x comma y is a function of image noise, and b of x comma. So here we are representing in mathematically, we are representing image using a function. So a of x comma y is a function of a noise image, h of x comma y is the function of image noise, and b of x comma y is a function of original image. So like this, we can we are trying to mathematically represent the concept of noise in the image. Like you can see, you can write like this. Next is, and this noise, this type of noise, the signal dependent degradation is known as additive noise. This word you remember, additive noise you remember, and this is a signal independent degradation. The signal independent degradation is called additive noise. Remember additive noise and signal independent degradation, and remember this formula: noise image equal to original image plus image noise. Next is like what are the different types of noises are there? Like as you can see, multiplicative noise. Example: multiplicative noise. Noise means like you can clearly observe when you are watching television. If there is some problem in the television lines, you automatically see some blur lines with the image is appearing, but still you can see some blur lines on the TV. Somebody who is having experience of watching old TVs in your childhood days, you actually remember this a lot. While you are watching TV, if some problem is there, if some signal problem is there, some degradation is there, some multiplicative noise is there, then automatically you cannot see the picture very clearly. Clarity picture you cannot see. When the picture is appearing, you see some lines, horizontal lines or some vertical lines appearing on the image. So this is a kind of multiplicative noise that will occur, and that's an example in television, that raster degradation. And the noise may occur while you are performing the quantization also. So generally, as you know, analog image is there, and analog image you are converting into digital image, right? Yes or no? So while you are converting analog image into digital image, you are performing two operations. What are they? What are the operations you are performing while you are converting analog image into digital image? Anyone? Sai Managna, quantization and sampling. Okay, very good. Sampling and quantization. Okay. So sampling and quantization we are performing while you are converting analog image into digital image. So here you can see quantization noise will occur. There may be a chance while you are converting analog image into digital image. At that time also you can find there will be some noise added. Then why the noise is added? Because of the insufficient quantization levels. The quantizer, there is a sampler and quantizer is there. If it is not properly working, if there is any problem with the quantization, when insufficient quantization levels are used, so then at that time there may be a creation of quantization noise, and it can be eliminated easy manner. So there is specific quantization levels that we can use for each type of category of image, like monochromatic image, 50 levels for monochromatic image. So like that, you should be able to use the sufficient levels of quantization while we are performing the quantization. Otherwise, the quantization noise may be also added in the image. So this noise can be eliminated very simple manner. And there is another noise that is referred to as impulse noise. Impulse noise is also referred to as salt and pepper noise. Salt and pepper. The other name of impulse noise is salt and pepper noise. The image can be corrupted with individual pixels whose brightness differs significantly from that neighborhood. You can observe by noisy pixels. The image is corrupted with individual noisy pixels. So here, in case of this impulse noise, image is corrupted and noisy pixels have brightness differing. The noisy pixels have change in brightness compared to their neighborhood pixels. So that is why we are going to use a term called as salt and pepper. Impulse noise is also known as salt and pepper noise. Okay, so additive noise and quantization noise, impulse noise. Okay, so all these are like salt and pepper noise can corrupt binary images also, as you can see. Binary images also it can corrupt. The images gets corrupted using these noises. We have to remove these noises from the image. And if you want to know in detail about the noise in the image, using mathematical functions, I probability density function for each and every type of noise. Generally, what I discussed here, only 4 levels. You can write these 4, it's enough. If you can describe well, additive noise or Gaussian noise, multiplicative noise, quantization noise, impulse noise. All these 4 types of noise are enough. If you want to write in detail, like noise modeling we have so many other types of noises. Gaussian noise I explained. Impulse noise is already there. Exponential, gamma noise, uniform noise. If possible, only you can write. These 7. Otherwise, you can write these 3 slides. In detail, you can write about these 3 slides. Noise in the images. And Gaussian noise, there is a formula. Gaussian or normal distribution. So this Gaussian noise affects, you can add some points from the first noise modeling. From this you can add some points which are not covered in those 3 slides. The Gaussian noise affects both dark and light areas of the image, and there is the formula is there here. PDF probability density function of a Gaussian random variable. And impulse noise is also known as short noise, binary noise, salt and pepper noise. The problem with impulse noise is that it mostly occurs because of the sensor problem or memory problem, because of which the pixels are assigned incorrect maximum value. This point also you can add. Impulse noise we discussed in the 3 slides. No, so this point you can add there. Pixels are assigned incorrect maximum values. And Poisson noise, this is used in X-ray images. This noise affects random structure or texture in the images. The texture of the image can be changed, the structure of the image can be changed due to this type of noise, Poisson noise. And exponential noise and gamma noise occur mostly due to the illumination problem. So exponential noise is present in laser imaging. There are laser imaging technologies, whatever are present today in medical field we are using. So in such type of images, there may be some exponential noise present. So the previous example, like you are taking X-ray images. When you are taking X-ray image, if you have some fracture, something like that, injury, most people will go to hospital to take X-ray images. And while you are taking the X-ray images also, there may be some noise will be affecting that image, that is affecting the clarity of the X-ray image. So that type of noise we refer to as Poisson noise. When we are capturing the image, if there is any sensor problem or memory problem, the image is not clear, then that kind of image, what do you say, disturbance. Noise is nothing but in a kind of way disturbance. It is a kind of disturbance that we see in the image. The image should be very crystal clear, but it is not appearing very clear. The best example I just now told, multiplicative noise, is TV only. TV channel, you are watching a particular TV channel, you can see the horizontal lines coming while you are watching the movie or while you are watching a serial, something like that. That means it's a kind of whatever you are seeing, like lines, extra horizontal lines or vertical lines, are disturbance to the actual image. The disturbance, we call it as a disturbance. This also you can write. The quantization noise we discussed, no? Just now quantization noise, because of quantization noise, there is one more noise occurs that we refer to as uniform noise. And there are probability distribution density functions for each and every type of noise. If you know maths, you can understand probability of z is equal to 2 by b z minus a e power minus z minus a whole square by b. And for all these, you can see mean and variance. Mean and variance. What is a mean and what is a variance? So this mu is referred to as mean, sigma is referred to as variance. So we are writing the probability density function using for the like a Gaussian random variable. This is a formula. I think you don't remember this formula. At least write the theory. Explain what's the reason behind every noise. So here impulse noise occurs because of sensory and memory problem. Poison noise, if you write about poison, for example, as an extra point, poison noise occurs because of X-ray images. So noise based on correlation also there. Photon noise are there, photon noise, quantization noise. So these 2 points, first 2 slides important. Additive noise, multiplicative noise that we discussed. Additive noise like this. G of x comma y is equal to f of x comma y, n of x comma y. Noise, image noise function and the image function. Multiplicative noise, like you can see, this is also mostly present in medical images. F of x comma y plus f of x comma y into ng. Ng represent noise. So here ng represents noise. So you can just go through this. And I just want all of you to prepare basic definitions. You can write down if you don't remember what I'm saying, because I'm talking about something which is important to your mid exam. So you can just prepare the definitions. There are a lot of definitions are there. So histograms, you can add these points. If possible, I will add these slides in the image. If you can understand this, you can also try to explain. Histogram has digital image typically has local minimum and local maximum. Histogram of a digital image typically has local minimum and local maximum, which may complicate further processing. So this can be avoided using the smoothing of histogram. You can write the formula if you wish. And this is how you are converting image into image histogram. The image is a grayscale transform image. You're converting into a histogram using the frequency and pixel intensity levels. And just read these definitions. What is an entropy? What is an acuity? The acuity is the ability to detect details in the image. The human eye is less sensitive to slow, and just read this, you can understand. But go through the definitions of acuity and entropy. And first topics I explained, like what is an image, and what is image processing, what is a pixel, what are the types of images, what is the difference between binary and black and white. So types of images I explained, no, that may be asked as a short question. Types of images. How many types of images? I asked this question several times. Types of images. Type in the chat box 4. What are they? 4 types of images. So there may be a question, short question with respect to that. Grayscale, binary, black and white. What is the difference between binary and black and white? Simple question only. One more question. And what is the difference between grayscale and color image? A simple. Right. Very good. Some people are responding. Around 5 to 6 members are responding. Very good, guys. Thank you. And next question, I think that you have to prepare it on your own. I'll tell the question. If you can prepare it on your own, you try. But I already covered almost all the questions except one question. Like what are the different topological properties of digital images? Topological properties in the sense you should be writing about pixel adjacency, region. If you can prepare it on your own, you can prepare. Pixel adjacency is one. What is a pixel adjacency? What is a region? What is a hole? What is an edge? So this you can prepare. This is an extra question. Remaining all I have covered. So if you can prepare what I explained to you in these 2 days, I am sure that you will get pass marks. I will get around 12 plus or 15 plus marks. If you can write the question as correctly, you can write the answers correctly about what I like applications, everything in detail. Applications of image processing and distance metrics, histogram, image sampling. If you can understand image quantization, you can write image sampling. If you can understand image sampling, you can write image quantization. At least whatever I explained, you don't have to write everything that is there in the textbook and every point should be covered. But if you listen my class and if you look at my PPT, what is there in the PPT, at least you should be able to write. That is enough. Because I'm not asking you to be like write everything, each and every point. At least, but you should be able to elaborate in a good way, good manner. And if possible, write mathematical description, mathematical function, if you can remember. One question I am giving you to prepare on your own is like a topological properties. Topological properties of digital images. Metrics I explained, distance metrics I explained, distance measures. Topological properties you have to prepare it on your own. Like a region, already results where a region is a set of pixels where the path between 2 pixels, like any pair of its pixels. You can understand easily this one also. Path from pixel P to pixel Q is a sequence of points A1 and A2. I don't want to read this just like that. You can prepare this. Region and image properties if you want to write hole and edge. If I can find any other PPT which is explaining better about these properties, I will share and you can easily understand. So till that time, you just prepare what I explained to you, right? That's enough if you can prepare what I explained to you. And don't forget to prepare applications of image processing. Around 5 domains are there: medicine, defense. You have to write in detail. If you can write correctly, you can write all the points, you'll get full marks. Right? And assignments, as I told you that you have to prepare and present at least 5 to 10 minutes. And I've observed that nobody is coming forward and everybody wants to write assignment like on paper. So guys, actually I am also learning a lot. Like if I give you a topic and you don't find the right YouTube videos, you don't find the right faculty who is like IIT faculty or NIT faculty, NPTEL videos, if you are not able to find that video, if you are not able to understand the topic, I will also search the relevant videos and share with you. You can prepare and explain. But I want all of you to prepare and explain about the topic. Okay. So don't take it for granted, because if you want assignment marks, first mid 10, second mid 10 marks are there, no, total 20. The 20 marks, how many marks you will get, that is up to you. So if you give presentation, based on that, I am going to give the assignment marks out of 20. But till now, I did not get any confirmation that how many of you are going to participate. If you can give me confirmation, then first mid, because anyway I have to give it separately. First mid 10 separately and second mid 10 separately. So if you give me confirmation that who are going to participate, for sure 100%, I will give them at least some good marks in the first mid and second mid. So think about that. Give me confirmation that you are going to participate. Whoever is interested to participate in presentations, give me confirmation, so I can give you proper assignment marks. Otherwise, you lose assignment marks, right? And I'm giving you one topic to prepare it on your own. Is like topological properties. Topological properties, you have to prepare it on your own. So thank you guys. That is all. I've covered all the topics which are necessary for your mid exam. If possible, any topics are skipped or any topics you don't understand, we will I will again explain in coming offline and online classes. Don't worry. And but I want your participation. So I will share today PPT also. Don't worry. Whatever I explained today, I will share the complete PPT total. Whatever I explained in the classroom, whatever I said to you, I will give that PPT to you. You can prepare that PPT, and if you are not able to write from the other PPTs or notes, you can just elaborate from the PPT I have given to you. Okay. So thank you, everyone. Thank you, guys. I am leaving this meeting, ending this meeting. Thank you. Thank you, 5E1. Thank you.